Hi everybody, so we're looking at the atom today, and this is just going to be an overview of a few different parts to the atom and the atomic structure as a whole. So the first part will be the subatomic particles, and then we're going to look at the atomic number and atomic mass and what do they actually mean. And then we're going to move on from to there to the electron configuration and the Bohr diagram. We'll practice some drawing. We're not going to look at bonding or anything in this lesson. That will be done in another video. Okay, so look, to get started there, we'll start with the subatomic particles. So what's the story there? Well, we have three subatomic particles in total. We have protons, we have neutrons, and we have electrons. The students always get bogged down when they hear about subatomic particles, and they get confused. What does that actually mean? Well, let's just discuss what the atom actually is. The atom, and you've probably seen it before in diagrams, um, is a particle that makes up everything. It's essentially like a piece of Lego, that's a single piece of Lego that is the easiest analogy to it. Okay, and atoms literally make up everything from your, I don't know, your pencils there to your laptops to a piece of furniture to toasters. It doesn't matter. They really do. They make up everything, and they're tiny now, guys. We can't see them. Like if you were to use a microscope in school, that wouldn't even be good enough. You have to use a microscope that could be up to about 1,000 times stronger than that one. So they're absolutely tiny, and there's still so much we don't know about them. But for you guys, you just need to know that these atoms consist of these three subatomic particles. That's all: protons, neutrons, and electrons. Now, you need to know a few things about each of these. Not much though. Okay, first off, you need to know the charge. So the charge being, is it positive, negative, or neutral? It has to be one of the three. One of the three. So um, there's really no other way around this one except that you have to learn it off. Sometimes I think of neutrons being neutral. So therefore, if it's neutral charge, we put down a 0 here. Um, Protons, I think often P for positive, so positive charge here. And then electrons have to be a negative charge, which is a minus. Sometimes electrons are represented like this, with a small e and a minus. Okay, not always. Okay, but just to draw your attention to that. So look, that's the charge of the subatomic particles. Next, you need to know the location. So the atom, where is your structure overall, but where in the atom are they located? Well, there's two parts to an atom, and I'll just draw it there. The first part is the center, okay, is the nucleus. So the nucleus. Okay, so nucleus is actually means the center. So that's what the center of an atom is called, the nucleus. And then we'll go back and around the atom. Now I might try and draw this with no, I'll keep the grey color there. Around the atom, we have something called the electron cloud. The electron cloud. Okay, so let's get back to it. The nucleus and the electron cloud. So there's only two parts to an atom. Okay, and you need to determine where in these two parts are the subatomic particles. That's all these are. Protons, neutrons, and electrons are classified as subatomic particles. Well, okay, the obvious answer there for the electrons anyhow is the electron cloud. Okay, so that kind of makes sense straight away. So electrons are found in the cloud. So we'll do the electron cloud there. And the neutrons and the protons, they are both found in the nucleus. There's an awful E there. So if I can spell now, it would be helpful. So the nucleus and the nucleus. And that's really all you need to know. in respect to protons, neutrons, electrons for where they're found. So protons are positively charged, they're found in the nucleus. Neutrons are neutral, so they have no charge. Okay, they're found in the nucleus also. And electrons are found negatively charged. Okay, so they're found in the electron cloud. Okay, so they're around the nucleus here. I know that isn't the perfect circle there, that's in terms of spacing here and here. You'll have to try and be as accurate as possible in an exam, but it shouldn't affect your results too much, or your answers, I should say. Now, the atomic number and atomic mass. What's the story here? Well, let's just go down here to the bottom, and we can see our periodic table here. Now, as a junior cycle student, you need to be able to name and identify the first 20 elements. Okay, so that goes up to here. So Ca standing for calcium. Okay, you will be given a log table in your exam. So lots of students are under the pressure that they have to learn off these numbers up here and down here. They don't. Not learn off those numbers at all, guys. Okay, all you need to do is pay attention to the log tables and be able to read the periodic table rather than learn it off. Okay, so let's just pick any element between 1 and 20. And we're just going to say, for argument's sake here, nitrogen. It doesn't matter which one we pick, okay, but we'll pick nitrogen. And nitrogen has a 7 on top and a 14 down the bottom. Now I know there's a point here, 14.007, but in your log tables, you'll get it as one-digit numbers, okay, or sorry, no decimal points in your numbers, I should say. So it'll just be for you guys, you'll just see a 7 up here and a 14 down here. Okay, so look, we'll go back up here to our atomic number and so forth. So I'm going to draw it out here, what it would look like. Nitrogen, and there's a 7 up here, and there was a 14 down here. Okay, so what do those numbers mean? Well, both of those numbers are representative of the atomic number and the atomic mass. Okay, so an easy way to remember this, okay, is the atomic number is always the smaller number, no matter what. Okay, so therefore we can assume that the atomic number is 7. And then the mass number, so that's the atomic mass, same thing, is 14. Let's go for atomic there, so there's no confusion. Okay. Now, just to be careful here, guys, okay, because in some examples you're going to see, sometimes they swap these numbers around. So the 7 goes down here and the 14 goes up here. Okay, you'll see that quite often in some periodic tables or when you're looking at this overall. Okay, so just to bear that in mind, that it's not the top that's the atomic number, it's the smaller number. Okay, I really can't stress that one enough, actually, guys, that there is going to be a difference there. Okay, sometimes they do swap. Okay, so we have the atomic number and we have the atomic mass. That's grand, we know which is which, but what do they actually mean? Well, there's two definitions that you need to learn off here. You have to. You have no choice in this, okay? There is a bit of learning in chemistry, alright? And you're just going to have to do your best with this. Let's start off with the atomic number. So, the atomic number is the number of protons in the nucleus of an atom. Now, guys, with definitions, you have to be exact. Okay, I can't stress this enough. I say it to my own students the whole time. Okay, your definitions have to be exact. And I wrote it down as the number of protons in the nucleus of an atom. Did I mention anywhere in the atomic number electrons or neutrons? I didn't. Okay, so if you mention either of those two subatomic particles, then you're not going to get the answer right. Okay, your definition correct. Okay, I can't, like, I don't know, sometimes it just baffles me sometimes when students be writing out electrons over here instead of protons, even though they know what it is. So just, there's no excuse for not learning off definitions, to be honest. So atomic mass. So this is, let me see, the number, I'll just write it out, the number of protons and neutrons in the nucleus of an atom. Okay, so let's think about it there. The atomic number is the number of protons in the nucleus of an atom. So we now know in nitrogen there are seven protons in the nucleus of a nitrogen atom. And we also know that the atomic mass number, that there are 14 protons and neutrons in the nucleus of that atom. They're not 14 each, there's a 14 total. So if we wanted to figure out how many neutrons on its own were in the nucleus of an atom, well, all you have to do is take the atomic number from the atomic mass. So the atomic mass minus the atomic number, this is a formula you have to learn off, guys. So minus atomic number, okay, equals the number of neutrons. So if I take 7 from 14, then I'm going to be left with 7 neutrons, which makes sense because we already knew that there were 7 protons, okay, and so therefore the remainder of the 14 has to be the neutrons, which is also 7. Okay, now we're going to be going over this in more detail in another video, but for now, just to talk about the electrons there while we're at it, okay, if the element is neutral, then the number of electrons is the same as the number of protons. Now, you'll know if it's neutral or not, okay, and you'll be told. And for the most part, okay, the vast majority of the elements you will be dealing with are going to be neutral. And if you're asked for any element out of the periodic table, here, okay, and to write down the atomic number and the mass number and write out how many subatomic particles there are and stuff like that, okay, you can assume that the element is neutral, okay. You will be told if it is not, and I will use another video to go into that in more detail. So if we go back up to this, if there are 7 protons, then therefore, and it's a neutral atom, which it is, okay, you'll be told otherwise, therefore there are 7 electrons. Okay, this is why students put in electrons over here instead of protons. Okay, however, the definition is the number of protons in the nucleus of an atom. Okay, for atomic number. It just so happens that the number of protons is equal to the number of electrons. Now, if you think about it for neutral atoms, if you think about it for this one here, guys, we have 7 protons, 7 neutrons, and 7 electrons. That's not always the case. So just to bear that in mind. Okay, protons and electrons are often the same, but the number of neutrons, okay, which is 7 from 14, okay, isn't always the same. So just to bear that in mind. Okay. Now we're moving on to the last 2 parts here, and this now is about drawing the atom. Okay, so I drew the atom over here. You can see the general structure of an atom, but we didn't put in any of the electrons. Now we have to be able to put those electrons in, and we have to discuss the electron clouds in a little bit more detail. So first off, there's a magic configuration here that you need to turn off. Okay, actually I might do a different color for this one. 2, 8, 8, 2. Okay, you have to learn this off. Okay, and what it represents is the max number of electrons not a shell, sometimes we often use them as shell, an orbit can hold. Okay, so let's just to explain that in some detail there. So all of this represents the max number of electrons in an orbit. Now, you'll notice if you add them all up, they equal to 20. Okay, and remember how I was saying that for your periodic table and stuff like that, you only need to know the first 20. Okay, so that's why I went up to as far as 2 over here. For your leaving chemistry, you have to know more than 20. Okay, so it'll stretch on a little bit further. Okay, so I said the max number of electrons in an orbit. So let's just discuss what exactly these orbits are. So we're going to go back to our drawings there now, guys. And we'll start off here. Now, no, that's not a perfect circle. That's close. Okay, so we have our nucleus here. I'm going to write it in. And we said before that around it, we have something called the electron cloud. Okay, now the electron cloud is actually broken up into different sections. Okay, and we call these, each section are called orbits. So for instance, we have one orbit here. We have another orbit here. We have another orbit here. Okay, so we have all these orbits. Okay, going around the what's what I'm looking for, around the nucleus. I'm just going to push it over here. And it seems a bit confusing when you see it like this, but when we do it, we're going to be doing it step by step in terms of putting the electrons in. And just to clarify there, that these numbers here, okay, represent the max number of electrons in an orbit. So for instance, this is the first orbit here. So in this orbit here, there are 2 electrons. There's a max of 2 electrons that can go there. In this orbit over here, there could be a max of 8 electrons. And for this orbit over here, there can also be a max of 8 electrons. And if I did another one, there can only be a max for you guys 2 electrons in this one. In reality, there actually is a lot more than those 2 electrons. But because you only go as far as the first 20 electrons, for you guys, it'll only ever be 2 electrons in here. Now, we always fill the orbits in order, okay? For instance there, if I had, let's just say nitrogen, and we'll pick out nitrogen there because we were familiar with it from the last one. So nitrogen had 7 and 14. That was your shape here, I think it was. There we go. Okay. So 7 and 14, and we knew 7 is the atomic number, which is the number of protons nucleus of an atom. But we also know that if it's a neutral atom, 7 would be the same number of electrons as well. So for nitrogen, there's 7 electrons. So if we're using electron configuration, which we are, we're going to put in our 7 electrons now. So let me just see there. I'm just going to see if I can do a bigger dot for this. So the first orbit, which is this one over here, can only take 2 electrons. And I always put the electrons as far apart from each other as possible. We have 1 electron there, and we have 1 electron here. Okay, I know it's a bit confusing with all the lines. I'm just showing you now the gist of it. In the next example, we'll see it from scratch, and it'll be a lot easier. So 7. Okay, so 2 from 7 is 5. That means I have 5 more electrons. Well, the 5 electrons go in here. Okay, I know there's 8 here, but that's the max number of electrons that this orbit can hold. Okay, so we're going to put in our 5. And again, I put them as far apart from each other as possible. So 1, 2, 3, 4, 5. So that means the last 2 orbits there don't exist. Okay, let's count it up. We have 1, 2, 3, 4, 5, 6, 7. So that is actually, this is called a Bohr diagram, and we're going to be practicing those in a moment. Ooh, that's way too big. Okay, so this is called a Bohr diagram, named after Niels Bohr, who was a scientist, a Danish scientist, who discovered how to draw these diagrams. Now, do you notice how when I'm drawing here, it's in 2D for the Bohr diagrams? That's because it's too difficult to represent these on paper in terms of 3D. Okay, so we do it in terms of 2D. They should actually be, however, they should be 3D. Yeah. Just a quick note there as well, because some of you have started practicing doing these already. Sometimes, and it's perfectly fine, that you might put these and actually draw it out all together. It might be easier. I'll do it over here. Let me see, I'll just do it all black. So you know this is we'll say it's nitrogen again, okay? So I'll just do it nitrogen there, just to represent that. Sometimes instead of drawing a nucleus, you just put an N inside there and you go straight to drawing the electrons in, like so. Then you do another one. And we have our 5 in this one, so 1, 2, 3, 4, 5. Again, it doesn't matter where they go, the electrons, as long as they're far apart from one another. So sometimes people draw it like this. Perfectly fine to do so, guys. Okay, there's no hassles whatsoever. You can do it either way, okay, this way or this way. I was just showing here that this was where the nucleus was, okay, in the center. But often when I'm doing mine, I actually prefer doing it this way because it's one less circle to be dealing with. And I don't know, I just kind of get, when I'm rushing with these, I can sometimes mix them up. So I'm probably, when you're going to see me doing it from now on, you're probably going to see me doing it this way, that I have it at the bottom. Okay, but if you did it this way or this way, you don't lose any marks whatsoever. Okay, it's perfectly fine. Okay, let's practice. So this is the last part of the lesson that we're going to focus on. And this is the Bohr diagrams. So we're just going to practice 1, 2 of them, that's all. Okay, and I will point out the mistakes that students often make for these. So look, let's pick another atom. We did nitrogen already, so we'll pick something different there for the sake of us. And we'll say aluminium over here. So we have a 13, and it's Al, 13, and that's 26.9, so we'll call that 27. That's what it looked like on your exam papers anyhow. So Al, grand. Notice how it's capital A and lowercase l for the second one, it's always that way. And what did I say again? I completely forgot. 13 and 27. Okay, and we put our little box around it. Grand, like so. Okay, let's draw the Bohr diagram. Well, we know the electron configuration is going to be 2, 8, 8, 2. That's the order it has to go in, and that's the max number of electrons in its in each orbit. Okay, so I draw in my Al here, and I put a circle around this. This is going to be my first orbit. Okay, so I'm going to go straight to the orbits. Now you don't have to do a different color, but I often do. Okay, for the electrons, just to help me out here. Okay, but you don't have to. And we know for the first orbit, it can hold a max of 2 electrons. So I have to do my 2 here, 1, 2. Okay, next I'm going to move on to my second orbit. Oh, that is not a circle. Yeah, a little bit better. Okay. And for the second orbit, it can hold a max of 8 electrons. Now, first off, how many electrons have I got left? I removed 2 already, or not removed, I drew 2 of them already. So 13 take away 2 is 11. So that means I have 11 more electrons to play with. So let's just put them in. I can put in the 8 straight off here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, if I count this up, I have 8 in this orbit over here and 2 in this orbit over here. Okay, so that means I have 10 electrons in total. I have 3 more electrons to play around with. So I draw in my next one, my next orbit. Thank God for notability. And I just draw 1, 2, 3. Okay, that's all you have to do. Now, before you continue on, okay, double check everything. Okay, first off, you have to count up all those electrons. And I can't stress this enough, guys, okay? The amount of times, and I've corrected junior cert papers now a few times, and the amount of times I find that students miscount the number of electrons is actually shocking. Okay, so just go back, it takes you 2 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Grand. Okay, the atomic number is 13, therefore there's 13 protons, and it's neutral, so we can assume that there's 13 electrons. Okay, does it fill the requirements of the electron configuration? Well, 2, 8, that's fine, and then there's 3 here, and there's a max is 8, but we can only put in 3 because that's all that we have left, so perfectly fine. What was I going to say there? Oh, just a quick thing as well. If you make a mistake in these Bohr diagrams, okay, you have 2 options, and only 2 options. Because most of you will be using pen when you're doing it, because sometimes pencil doesn't come through on the scanning machines, depending on the darkness of it and so forth. But we'll assume you're using pen. First option is, if you make a mistake, is to cross it out, okay, completely get rid of it, okay, and do it again, okay. I know it seems tedious, but like there's a good few marks going for this. The second option, and this is what usually happens, is that students, they're going to put in too many electrons. So they'll do something like this. Okay, so first option, like I said, is to get rid of it completely. The second option, sometimes the better option, if you ask me, but depends on school policies and stuff like that, is to tip X it out. So you could just tip X this one out. Okay, and you're grand. Now, what I don't want to see happening, and this is usually what happens now. Okay, so students go like this, and they'll realize that they have an extra electron, and what do? They'll go over here and they'll do X around like that, or a squiggle or something on those lines. Okay, it's usually when students do that, okay, it's usually not very clear whether they're trying to get rid of it or whether they just drew a funny electron, a funny looking electron. You'd be surprised at how often that happens. And very often, okay, examiners are told, okay, not to assume that the student is correct, okay, because if we're not sure, we're to assume that you're wrong. And very often we'll mark you wrong, or you'll lose some of the marks or whatever. Okay, so I don't want to see you guys just doing an X there or crossing it out. Okay, you either cross out the entire thing, okay, or you tip X's out. Okay, I don't want to see any scribbles on it. It's no good. And another mistake the students make, and it's kind of the most tedious ones, is they make it tiny, so it cannot be seen. Like, this is a fine size there, it's nice and big. But like, if I made that smaller there, okay, like it's actually still readable here, but that's because I'm using Notability, okay, and it's doing the circles and stuff like that, make perfect circles for me. For you guys, it won't do that, okay, and it'll look a lot more messy. And it's very difficult for the examiners to be reading, counting the number of electrons. And you have to remember that examiners have, like, we could have about 300 scripts correct, depending, okay? And we only have a certain amount of time to do it. And you're just a number, you're not our students. So we're not going to spend massive amount of time in terms of counting those electrons if you're not making it very clear. So I can't stress that enough. Okay, look, we're going to do one more, and we'll go from there. I'll get rid of that there. I'll get rid of this one over here. We'll pick something that has a bit more in terms of the number of electrons. So when we say, look, we'll say chlorine there, Cl, and it's, or even argon actually. Argon's even better. 18 AR40, I remember that. 18 AR40. Okay, so we write in our AR over here. I use black for marker for the rest of us. So I draw in my circle. That's going to be my first orbit. Okay, and I'm going to put in my electrons. Okay, so I have 18 electrons to put in. Okay, so I definitely have enough, and the first one can only take 2, so put in 2 here. I now have 16 electrons remaining, so I'm going to put them in. Draw in my next orbit. And I definitely have enough here again, so I'm going to put in my I'm going to put in my electrons again here. So 1, 2, 3, 4, 5, 6, 7, 8. So I have a total of 10 electrons. I need 8 more. So I draw in my next orbit. Okay, and I now put it in. So I have 10 electrons. So that means I need 8 more, which will actually fill up this orbit nice and handy. So it'll be a full orbit. So 1, 2, 3, 4, 5, 6, 7, 8. Count everything and always start from the middle, the nucleus. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 electrons in total here. Okay, you can see the diagram is a nice size, in which it's quite big. Usually you want the size of a diagram to be the size of a closed fist. I stick to my electron configuration rule. That means I can only have a max of 2 electrons in the first one, a max of 8 electrons in the second one, and a max of 8 electrons in the third orbit. Okay, and yeah, I'm done then. That's my Bohr diagram done. And you should be able to do this for any of the first 20 elements. So just to quickly recap there, very quickly, subatomic particles, you need to know that their names, protons, neutrons, electrons, you need to know their charges, and you need to know where they're located. The atomic number, atomic mass, 2 definitions you need to know off by heart. Okay, they get asked too much for you not to know it. Okay, and then there's a formula there that you need to learn off as well. Okay, and that is the formula for the number of neutrons. The electron configuration ties in very much with the Bohr diagram in this that the max number of electrons in an orbit. The first orbit can only hold 2 electrons. The second orbit, 8 electrons. Third orbit, 8. And the final one, 2. Now, in reality, the final one can hold a lot more than 2. Okay, but because we only go as far as the first 20 elements, our max for junior cycle is going to be 2. There's 2 ways of drawing it. Okay, both very similar. Okay, in one way you just have a nucleus in it, and the other way you don't. Okay, it's up to yourself if you want to do that or not. I prefer it without the nucleus myself, simply because there's less circles. The Bohr diagram we practiced there, and we know that the atomic number of a neutral atom will have the same number of protons as it does electrons. Okay, and you will be told if it's not neutral. And I will be doing another video very soon for those ones. So guys, look, I hope you took something from this. There will be a few more videos coming up shortly, and yeah, look, I hope they helped you with your revision. Best of luck now.